Hello friends, welcome to my channel. In this video we discussing about the method of design of RC. The aim of design is to decide the size and area of reinforcement so that the structure will perform satisfactorily during life period and within minimum cost and within appropriate degree of safety. The design of reinforced concrete members sustain all loads and sustain the deformation during and after its construction, and it should have adequate durability, and it should have adequate resistance to fire. What are the loads acting on the structure are dead load, live load or imposed load, and wind load, earthquake forces, snow load, shrinkage, creep, and temperature effects. These are acting on the RC member. Dead load is the weight of the structure acting on it. Live load is the weight of the moving persons or things on the structure. And wind force, earthquake force, snow, we all know that. Shrinkage and creep we discussed in the last video. Temperature also we know that. Working stress method, ultimate load method, limit state method. These three methods have been developed for the design of reinforced concrete structure. Let us discussing about the working stress method. This method is also known as elastic method, modular ratio method, or factor of safety method. Working stress method based on elastic theory assuming. That the both steel and concrete act together and are perfectly elastic at all stages. It assumes a strain compactability in which strain in reinforcing steel assumed to equal to the strain in concrete. Consequently, the stress in steel is nearly equal to the stress in adjoining concrete by a constant factor. That constant factor is called the modular ratio. It represented by M. It is the ratio of the modulus of elasticity of steel to the concrete. In the working stress method, permissible stresses are obtained by dividing the ultimate stress by factor of safety. Factor of safety value different for working stress method and limit state method. In the working stress method, factor of safety values for concrete 3, for steel 1.78. Let us discussing about the assumptions of working stress method. First, at any cross section, plane section before bending remain plane after bending. All tensile stresses are taken by reinforcement only. The stress strain relationship of concrete under working load is linear, a straight line. The modular ratio equal to 280 by 3 sigma CBC, where sigma CBC is the permissible compressive stress due to bending in concrete. In Newton per mm square. These values are available in the table 21 of IS 456 2000. Sigma CBC values are also calculated by manually. For example, M20 grade concrete, we have to find sigma CBC equal 20 by 3, 6.6. Answer. It roughly taken as 7 Newton per mm square also. C equal to grade of concrete by 3. Remember this formula are taken value of sigma CBC by using codebook also. Next is drawbacks of working stress method. The first drawback is stress strain curve for concrete is assumed as linear, but practically which is not true. And factor of safety doesn't predict the true margin of safety. The failure criteria assumed is stress, but strain criteria is the reliable. This method assumes only stress. The effect of creep and shrinkage of concrete is ignored. Next, this method gives uneconomical sections because the section dimensions is very large compared to the other methods. That's why this method has been deleted in IS 456 2000, but the concept of this method is retained for checking the serviceability, states of deflection, checking the deflection and cracking. Hence, the knowledge of this method is essential and IS 456 2000 gives it in the appendix. Let us discussing about the ultimate load method. In this method, structural elements are designed for ultimate loads, which are obtained by multiplying the working loads with load factor. Then the structure can carry beyond the working loads without collapse. Hence, this method gives the true margin of safety. This method considers the actual stress strain curve of concrete and failure criteria is assumed as ultimate strain. And this method gives economical sections. But this method leads to excessive deformations and cracking. Thus, this method is failed to satisfy the serviceability and durability requirements. This is the ultimate load method. To overcome these drawbacks of the ultimate load method, we use limit state method. Both take care of strength and serviceability requirements. In the next video, we discuss about the working stress method, design of singly reinforced beams. Thank you for watching this video. Please like, share and subscribe to my channel.